Welcome back, everyone. So for this session, in this session, very short summary. I'll briefly explain how I think you can use LLMs in your code base, so that it becomes very easy to benefit from all the power of LLMs and use it while coding, so that you get data from the LLM in a structured way. Very briefly about myself. So yeah, my name is Pieter Buteneers. I'm the CTO of Structize AI. And basically, we started our company in March this year with the main idea of extracting structured information from documents, from unstructured text, basically. We did a lot of things. We tried a bunch of experiments. One of them was that you can just create a simple Excel template with tags, and we automatically create prompts and extract information from it. That is now all history. It still runs. You can still use it. But we found a very interesting niche to work on, and that's the niche of legal M&A due diligence. So if you buy a company, you typically want to know whether they have all their contracts and legal documents in order. We do the scan for that to automatically find liabilities and red flags. If you want to know more about this legal tech or any other way of extracting structured information from unstructured text, just come and talk to me after the talk. But I hope that with my presentation, most of the insights are there for grabs. So let's maybe make the difference between APIs and LLMs. So APIs, well, whoa, there's a weird echo. So APIs, they always work as intended, right? At least good APIs, right? You always get the same output. And the output format that you get is very consistent. It's always the same unless they do a version upgrade or something, but usually they don't randomly change that. And a good API is fast, right? Then let's look at LLMs. What are they like? Well, they don't always work as intended. The output is always different, like always or almost always. The output format is not consistent at all. I mean, it's continuously changing. You have barely any control over it, and they're really slow compared to APIs. So basically, they have none of these very important qualities that an API should have. So you might say, okay, let's fix it, right? Let's find a solution for it. And that's basically what this talk is about, like how, well, I don't know what the beep is about. How was I able to fix it, or at least some of these things? Now, the first thing you have to do, and yesterday during the business workshop, I see some people from yesterday here as well. We gave a mini workshop on prompt engineering, but I'll give you a few of the highlights that are useful in this context. So the first thing is maybe very easy to remember is Raft. So basically you assign the LLM a role. In our case is you're a lawyer specialized in M&A due diligence. That's a role. Give it some areas to focus on. In our case, it's you look for liabilities, and then you define the output format. What we typically define is a JSON. We want a JSON out because then we can easily embed it in the rest of our code base, typically what you have from REST APIs, right? And then we do the good old thing, try, and try again. And what most people underestimate is the T here. Don't expect an LLM to work really well. If you do these steps very good, you don't have to try that often. But usually you try something and then you realize, oh, it seems that the model didn't get this part of my explanation. Or maybe I missed this part in the context that I provided. And you try again, you give it maybe a bit more context, a bit more information, and hopefully the next time around it works really well. So I made a quick example on how you can do this. This is just simple Python code. So I just import the OpenAI client and I put some messages in place. So typically you have a system prompt. So the system prompt kind of defines the role. In this case, I say, well, you're an API and you return messages in JSON. and you know everything about countries and their presidents, and the output format is country, country name, president, president name. And then I ask a trick question. The trick question is, who is the president of the EU? And then there is the rest of the code to run it. You can just copy paste this if you want to. It's very straightforward. I just copy pasted it from a demo on OpenAI as well. So if we run this, what is the output? Well, you get a text that starts with --JSON, so it's actually Markdown that you get. It's not a JSON that you get. And the country is European Union, and then president, it comes up with a whole text. It's already outdated, but I kept it just for fun. And it will say, well, the president is Ursula von der Leyen for the European Commission, but then there is this Belgian guy who turns out not that many people like, is the president of the European Council. So yeah, who is it, right? And it's not you don't get a clear answer. So this is, yes, it's a nicely structured output, but it's not super consistent, not something that you can use in just about any context. So what you have to do is try a bunch of new prompts, and you can just try the same thing again, just for sports, without changing anything. And then you will see that all of a sudden it does give you European Union and Ursula von der Leyen. So again, same output format doesn't work. You just try again, you get a different output. So let's try one more time and see what happens. And then it doesn't say European Union anymore, it says European Commission. Again, another output. So this is, I think you can agree with me, not usable for as an API in your code base, because you get, I mean, you try it 3 times, you get 3 different results, right? So what can we do to make this better? This is what we call zero-shot or many-shot learning. So what is one-shot learning? So zero-shot learning is what you saw before, no examples. One-shot learning is just add 1 example. Two-shot learning, 2 examples. Three-shot learning, 3 examples, right? You get the hang of it. And then we have many-shot learning, we just add many examples. So what would that look like? Basically, we just change the user prompt with an extra example. You can also put it in the system prompt, doesn't really matter. But for example, the question is, who is the president of the European Council? And that guy used to be Charles Michel, our Belgian former prime minister, and the country is European Union. So at least you make it clear to the model that you really want an actual country and a name of a person and not much more than that. And then you can ask, okay, who's the president of the European Commission? And then you get this output, country, European Union, President Ursula von der Leyen. Fine. Now, what we had not so long ago, obviously, is elections, and things changed a bit. So what you have to do at that point is, well, you have to provide the system with new information. If there is no new information, it can't know. So how will you do that? The way to do that is work with RAGs. And let's start without the R, just the A and the G, augmented generation. So the idea is that you just provide a document with information. The easiest way in this case to do it is just have a list of all countries and their presidents as an input document, and then ask the question. You'll get a much better result. So this is just adding a document as extra content to your prompt. And then we have another thing called retrieval augmented generation. This is where you augment your prompt with information that you retrieve from basically a search engine. This can be Google, this can be anything. It doesn't have to work with embeddings. I mean, if you have very good keyword search, it works really well. And typically combining the 2, keyword search and embedding search, works even better than just using one of them. So basically you use search results to improve your results. So remember this pro tip, combining keywords and embeddings, way better than just one of the 2 if you ever try this. Then, obviously, LLMs tend to hallucinate, right? They tend to come up with new information. And what really helps to avoid this is to be very specific and detailed in your prompt. Clearly state what you're looking for and what you're not looking for. That helps a lot. Another thing that you can do is just do a second prompt to check if the answer is made up. So basically you take the original input and output, you give that as input to another system, and then you ask, okay, is the output information present in the input or not? And if it says it's not present, then you know that it's made up. So how do you do this in practice? Well, you just have a query, it generates an output, maybe you get some extra information from a RAG or somewhere else, and then you just validate this output with another prompt, and if the validation is not correct, you try again, and you can just say, hey, I checked this, and I found this weirdness in the result, improve it, and it will just improve it, and actually works pretty well. If you ever tried prompting yourself and you say like, hey, this doesn't seem to add up, then you see that the model is sometimes able to correct itself. And if the validation is okay, then you have your validated output and you can return it. So this is not only applicable for hallucinations, you can also use this to check for other unwanted content like bias against, well, women or other races, or even if you really want to middle-aged white men, right, you can check for any bias that you can find, or you can even check for any unwanted content that your system produces. Just having a critic in place to analyze the output works really, really well. Sounds simple. You might think that it's absurd to use the same system to check itself, but if you provide it with a different context and specifically ask for this, this works really, really well. So just build the second validation prompt to check your output. Now, consistency, this is one thing that we saw before, right? The output of OpenAI is always different. It's not always the same. Even if you have the best possible prompt, there is no guarantee that the output format will be the same. So if you Google this, then you find like, okay, what you have to do is set the temperature to 0 and set the seed to a fixed random number. 1, 2, 3, 42, whatever rocks your boat. That's what Google says that you have to do. We all know that Google is outdated by now, but sadly, if you ask ChatGPT, it doesn't tell you anything more than this. So in a quick demo, this actually works fine, and you think like, oh, I've solved this problem. I don't have these issues anymore, but in reality, you're completely wrong. Every now and then, you still get completely different outputs than what you were hoping. And it is impossible to do it with OpenAI this way. Even if you set the temperature to 0 and a fixed random seed, you still can get different outputs. And the reason for it is that under the hood, what they use is probably, most likely, a mixture of experts model. Now, if you don't know what that is, basically what you have is that the models of OpenAI, they consist out of multiple sub-models, multiple small experts basically that come to an output, and the average output, the average of those experts is sent to you. Now what they do to optimize the load on their servers is you don't get all the experts. If there are 10 experts, you get maybe 3 experts, and the average output of those 3 is the one that you get. But to optimize load balancing, what they do is, well, the 3 experts that are actually best for your task, they're busy. So we'll just give you other experts. So even with the seed set to a fixed number and the temperature to 0, you will see that you still get a very different output every time that you do this. Because if there is suddenly a lot of load on the system, well, the output is different. So basically, if you ask, in this case, I used Microsoft Copilot, what it is, it actually gives you this answer. So you can use these tools to figure it out and basically figure out why it's like that. Just a quick caveat that you can actually use these kind of models to get to your answers. There's one solution for this, and that's using Anthropic, but only the old version of Anthropic. So not Claude 3.5, but Claude 3. Claude 3 works really well, and if you set the temperature to 0 and the fixed t to a fixed number, you actually always get the same output for the same input. But this model is already outdated. You can still get it at Claude or on Amazon, but I don't know for how long. But this is one way to do it. So it seems that Claude 3 doesn't use a mixture of expert model, or they're not so cheap on their load balancing. So just use Claude 3, set the temperature to 0, and that's basically all you need to do. Here's a quick code example where I just import Anthropic. You have the same thing. And if you use, for example, Claude, this is wrong actually, if you use Claude 3.5 Sonnet, it actually doesn't work. So you need to use Claude 3, set the temperature to 0, and get your output, and it will always be the same. And as you can see, then you get this result, and if you try it 10 times, you will always get the same output. Now, output format changes, this can definitely happen. So even if you use Claude 3 Sonnet and try this snippet of code, you can get these kinds of outputs. So sometimes it's like a bit of text and then a JSON, a bit of text and a JSON. But the JSON is also not always the same. So here it might be institution, leader, role. You get all these different kinds of weird things that you actually didn't ask for. And you might think, like, why is it doing that? Well, it is because these things are just made to generate convincing text. They're not made to be embedded in an API. So what you have to do is to check the output format. And the easiest way is just to, if the output format is not good, tell the LLM what it did wrong and try again. So basically it's, again, having some validation prompt in place that checks the output format. It doesn't have to be a prompt, it can be regular code, but make sure that your code produces some text that you can give back. Try again with the system and let it produce a better output. Now, if you've been reading a lot on this, you might have heard about function calling. So function calling is basically if you have a chat conversation that somewhere throughout the chat you allow the model to do an API call to some random API and get the answer. But in order to do an API call, you need some structured information that you can send to the API. And that's where function calling comes in. And here is a code snippet on how to do it, and you can add these tools. And this tool is basically sort of the API that you would call, but in this case we're actually abusing it to make sure that it provides country and president. And you can actually use this, and this kind of works, but you often, if you get asked it trick questions, it will generate a lot of text, but not the JSON that you're looking for. And also, if you use it in an API, this is another thing that you need to catch, and probably not the thing that you want. So this is not really helping in this case. And in our case, we maybe want it to be a bit more creative and not wait until it really has figured out the answer to who is the president of the EU, right? So it seems to be a lot stricter on hallucinations, which might be good in your case, but in many cases it's too restrictive and it actually doesn't give you what you're looking for. And it's definitely not very creative. Well, you can try with other models and see what it does. And if you try with the right prompt, you actually get, well, a text and then whatever you need to call your function. You can make it work, but your prompt needs to be good. So why don't we use it? Because, I mean, we could just use a better prompt. Well, it's really made for chat, and it's really made to trigger an API call, not return an output format to you. So you're not 100% sure that you get an output, and you're not 100% sure that whatever you ask for, you're getting at that point, even though that's what you typically would have with an API call. So for us, it was just a lot more work to make it work than do it the other way. So the thing is, in our case, we just can't chat with documents, right? That's not the idea. You cannot go back to the document and ask questions. The document is the document. If the information is there, it should be able to extract the information from it. There are tools like Guidance. This is one of them. You can check out their GitHub page that actually allow you to write some code to get really structured output from LLMs. It has this way of defining like an output format where you can just say, okay, I want to generate an age here between, which is a number or some strings or that kind of stuff. So you can really define what you want and what you don't want. It's pretty powerful, but it's also really, really slow because it will actually generate a prompt for every bit and piece. So you have to go every step all of the way if you use OpenAI. If you use some of the open source models, this actually gives you maximal control of what the next token is that comes out. So for open source models, this is awesome. But in our case, it was way more expensive to run open source models 24/7 than just use the OpenAI APIs because their prices dropped so much. Like in the last 6 months, it's dropped for us 4-fold. So it's a massive drop and it became just way cheaper to use this. And using Guidance was just too slow for us. But yeah, works really well for open source models. And as I said, the reason why it's so slow, it's because it's just for each answer to your JSON is one chat message and you have to go back and forth. And with the models on OpenAI, you continuously end back in the queue. You have to wait until your call is picked up and only then you get an answer. So you introduce a lot of latency. Another tool that is actually quite a bit better that I like a lot is Instructor. This is really created to get structured output from LLMs. So definitely check out their page. I chatted with a bunch of people yesterday as well. And it seems to be used by quite a few people. So definitely look at it. The code is actually pretty simple. So I just copy pasted this. And you can just have a Pydantic model, a base model, which is just the Python way of saying a JSON schema, right? And you can define that the name is a string and age is an int, for example, and give that as your response model and let it do its thing. And it actually works really well. You always get some form of output most of the time, but again, sometimes this fails. We tried it in our systems to extract information from documents, and basically it does everything under the hood that I showed you earlier, but for some reason it's way slower than my own code, and for the specific cases that we have, it fails more often than my own code. I don't know why. I'm just waiting for somebody to pick this up and do this right, so I don't have to do this anymore, but for some reason writing my own checks, and it's not that it's 10,000 lines of code, not even that. There are not that many checks, but my code tends to be faster and work more often. So don't over-rely on tools like Instructor. Maybe try, if you see it fails in some cases, try to write some of your own code. It's actually not that hard to write a check whether your JSON is valid or not, right? And create a new prompt to go back to the LLM and let it improve the output. Then there is the thing that we ended up using now in production that actually helped us the most, and that's the structured output from OpenAI. Basically solves all the problems that we're looking for, and it is using the same Pydantic base model as Instructor, but straight into the OpenAI toolkit. The only caveat that you need to know is that this is a beta feature. So we use it in production because we have a backup that can still go back to our old system. But if you don't have that, beware that this is a beta feature and that all of a sudden it might just crash and fail. Took a while also before this became available in Europe. So it only works with GPT-4o in Europe and on Azure, and not with GPT-4o Mini. I don't know why, but Azure is stalling, and I think they just want to make money out of the expensive model and not out of the cheap model, because it would work just as well with GPT-4o Mini for our use case. But whatever, it's the case like this, and we can't really change it. And this basically does everything that I discussed, but straight into the model of OpenAI, where it just extracts the relevant tokens and not other ones. So this works really, really well. What you do need to know if you go to more complex class structures, like with lists of objects and that kind of stuff, you might get some weird errors. Usually it's because your base model is structured the wrong way. Don't look at the error, because it says you have to specify a field, and if you do that, you still get the same error. Just start back from scratch, building your complexity, and then you get a pretty good model. But again, beta feature, be careful. It might break at any point, so be careful if you use it. Make sure you have a backup somewhere. So I can tell you, though, that it's really, really fast, and even though it's a beta feature, for us, it's been actually really, really reliable. Faster than my own code, and well, maybe even more reliable than my own code. Let's be honest. So basically, this does everything that you want. So if you want to try something, try it out, but beware that it's a beta feature. Soon, my talk will be completely irrelevant once this comes out of beta, right? And you can just use that. But for now, be careful that it's beta software. Yeah, as I said, by now most of the bugs on Azure are the same as on OpenAI. But in the beginning, Azure had way more bugs than OpenAI. They were lagging behind in versions, and some things that work on OpenAI didn't work on if you would use the OpenAI models on Azure. There are no other players. Like I would love to use Claude 3.5 Sonnet, which is actually better for legal text than OpenAI. It's a bit smarter, but Anthropic doesn't have this feature yet. It's been out since summer, so I thought I would have caught up by now, but they haven't. But still, even the OpenAI one still has weird bugs and weird errors that you get, so it doesn't always work that easily. One other thing, caveat that you know, because it's OpenAI, you can't control the mixture of experts, you can still get different outputs. So it does almost everything, but the output can still change. So beware that it's not exactly the same, but because you can neatly define the structure, most of the time, in most cases, what's relevant comes out more or less the same. All right, so once you have these results, maybe they fit all the requirements that you have, but you might want to have them a bit smarter. And one of the simplest tricks in prompt engineering is ask for a step-by-step analysis and rationale first. So let the LLM, and you can even embed that in your JSON, like have a rationale, have that as the first field in your JSON, in your structured output, and let it generate a nice rationale, and then generate the actual answer. You'll get way better performance, and actually just very simple. It's just one extra field in your JSON, and you get a much better output. So basically, what you just do is ask for, well, basically answer the question first with a step-by-step analysis of the problem, and save that as the rationale. Only then give the desired output. That's an example prompt that you can use. You can write your own. It doesn't really matter how to do it, but what you get is this: in your JSON, you get the rationale, which explains like step by step how it reasons, and then it will answer. And in this case, well, it doesn't really know the country, and it doesn't really know the president, because, well, it's a trick question, right? So you get a way more reliable result that way. Another approach, this is basically called chain of thought, right? You basically force the model to have a chain of thought, and you can also do this in multiple stages, where we do actually the same graph that I showed you earlier, where you have some form of validation give the output of the validation back to the model, and let it regenerate the output. So same story over and over again, right? Having a simple checker for whatever you want to check as a separate LLM prompt ready and use that output again as input in your chat conversation can actually help you a lot. So it doesn't only work for hallucinations, bias, and all that stuff, but also to get a more reliable output. And make sure that whatever you get from the validation model contains a rationale so that you can actually give that output back to the system and use that to improve the output. A pro tip can be, it's not necessary. If you don't have access to different LLMs, you don't have to, but a pro tip is to use Claude for one and OpenAI for the other, or the other way around, because it will see different things. It adds a tiny bit of improvement, so if you really want to go the extra mile, you can do it, but you don't have to. You can actually just use the same LLM model. These LLMs are actually very good at being critics, so that part they have covered. Being smart, on the other hand, they make a lot of mistakes. And yeah, keep going back and forth, and you have the result. And that's what we do, obviously, to get a reliable structured output. Now, you might think like, well, this doesn't work really well. Maybe I can just resort to fine-tuning. And to be honest, fine-tuning an LLM is really your last resort. Like, this is really the thing that you should only do if you have no other option. For example, to keep the model small so that you need very little compute to run it, then you can fine-tune, but it means that you need to have a lot of training data, and training data is really expensive. And yeah, the training data needs to be very specific to your problem, because otherwise it doesn't help. So usually it's very hard to gather this data. And if even fine-tuning doesn't work, well, maybe you have to go old school and do a fully customized model trained on labeled data. But to be honest, these two things, like custom model or even fine-tuning, become rarer and rarer. Every time these LLMs become smarter, you can do way more with prompting, with many-shot learning and this kind of stuff. So it becomes less and less relevant as we go. All right, well, faster LLMs, you can use smaller ones, but they're not as smart. But they get smarter every day, but still, they're not as smart. Fine-tuning will make it faster. Or you can use tools like Grok. If you don't know it, it's Grok with a Q, not with a K. Grok with a K is Elon's LLM that's pretty snarky and will give you unfiltered comments based on the Twitter data. Grok with a Q, those guys actually make hardware to run machine learning models. And they have an API available that's actually really, really fast, and that runs some of the better open source models for you. But you can just use OpenAI on Azure and Claude on AWS like we do. Occasionally we go direct, but it's only when we're sure that we can send the data to the US. For us, it's usually a big no-go, and the data needs to stay in the EU. Just know that if you can go direct, just go direct. I mean, you get better APIs. They're generally faster, not always, but generally. And you get way more throughput to these models than using the models on Azure and AWS. But you can. I mean, we have no other option. But if you can, go direct. Now, APIs, well, fairly simple, just some pseudocode here. Basically the same thing, right? We just use it asynchronously, and we just check if it doesn't match the format. We try again, basically. It's just some pseudocode to help you out, but if you turn this into an API, it's actually not so hard. I use AOHTTP. Historically, I tried this method, but my advice is not to use it. It has weird quirks. Just stick to fast API. It's actually better. But just in case, here's a snippet of code that you can use. Yeah, this is the rest of the code, how you handle the request and everything. I think pretty straightforward. very specific to HTTP. But again, if you use another tool, just use your tool that you like. All right, then you might hope that you can deploy this serverless, right? That you don't need to host an API. Sadly, the answer is no. For the simple reason that if you use, for example, Chalice on AWS to deploy Python code serverless, it can run maximum 29 or 30 seconds, and then it just stops. LLMs are still slow, and if you ask a lot of output, it's really dependent on the size of the output that you ask for. Like the number of fields in your JSON really defines the output speed a lot. So if you ask for a lot of output fields, 30 seconds is not enough. It will take way longer than that. So just be aware that this is an issue and that you probably need to run it in a Docker container somewhere. What we do is we run it on AWS Fargate, because the container doesn't have to do a lot of work, because everything is just asynchronous and just sending it to OpenAI and ask for a reply. We don't even bother with scaling. It can handle it pretty easily. We just run 4 tiny containers in parallel on Fargate and load balance it that way, and that's it. All right, conclusion. The title of my slides yesterday, well, GenAI really sucks, right? There's lots of issues that come up, but you can really make it work, right? You can really get something out of it if you learn how to do this. And you will be able to turn LLMs into more or less consistent APIs and embed this in your code base. All right, thank you. Are there any questions in the room or at home? I don't know if I can see the questions at home, but yeah, go ahead.
So in the beginning you mentioned about extra learning and giving examples in a first prompt and then prompting it to go by the example. Recently I saw both Anthropic and I think OpenAI a few days after them, I don't know if they copied it or is it planned, they added caching mechanisms. I don't know if you have any experience using that. So adding a prompt as a cache so you don't re-prompt it and waste tokens, because every time we give an example we have to pay for the tokens of the example. Yep. And we have large documents, it could stack up pretty easily over time.
So the question is around prompt caching. So,
do you have any experience using
yeah.
prompt caching?
Well, one of the things that you mentioned is around price. Actually, OpenAI supports prompt caching natively out of the box, which means that if you send the same prompt that you sent earlier, it is automatically cached, so you don't need to do anything. But these large APIs, they actually don't charge you less for it. You might get your response a bit faster, but they actually charge you the same amount, so they still count all the tokens. So you don't save money, but you do save some time. And my personal experience is that it's a tiny bit faster, but we didn't notice much difference. But Paul Dubbs, who gives a talk, I think tomorrow afternoon, about something on RAG and agentic workflows, you should check it out. But you can talk to him. He says, for us, these prompt caching really worked well, and they send a lot of the time the same prompt over and over again to the system. And for them, it was a big difference. For us, we actually didn't notice a lot of difference using prompt caching. There was another question.
Yeah, exactly. I wanted to ask you about OpenAI, the structured output.
Yep.
It works under the hood. So does it make like multiple requests and you are paying like, for example, twice, 3 times for the single request? Or is it like just adding some magic into the prompt itself under the hood and working better, or is it doing some post-processing? Do you know?
Yeah, so the question is around how does structured output from OpenAI work under the hood? So it doesn't work like guidance where you have to do a call every time and again and again. So it actually checks on the token probability level, like does this token match the output format or not? So it really just generates the output and just goes in and checks the probabilities of the tokens and only generate tokens that match the desired output format. So in that sense, it's actually pretty pretty cool. It's really built into the system, and you do get an extra charge for the JSON schema that you send over. So it comes at a small additional cost, but it's actually pretty reasonable. If I write my own custom generated prompt, it actually takes more tokens to get the result that I want than using the structured output. So for us, we actually save some money by doing it that way.
And the time, the generation time of the output stays the same, or is it like downgrading?
Yeah, so the generation time of the output actually with structured output is faster than with my own code, because with my own code, there's a lot more prompt going in, so that takes a bit longer, and I have a lot more checks I need to go back and forth. With structured output, you have a guarantee that the format is exactly what you want. So actually for us, it actually works a bit faster. Not much, but it does work faster.
That's cool, thanks.
So yeah, if you're open to trying beta features, definitely try it out. I mean, this was the solution for us. The nice thing about the structured output is that you can actually include definitions of the field. So basically the fields in your object, you can add definitions there. So basically a large chunk of your prompt is actually embedded into the JSON schema. So it makes it pretty easy to have like a standard output field for everything and just store the JSON schema every time, and you don't need to generate it every time. So pretty interesting. Yeah.
Just the last thing, like you mentioned the bugs, since it's like a beta feature. So the bugs means that it's just like returns, I don't know, error messages 500 and it dies, or it's like provide crappy response, or what does it mean that it's often create bugs?
Yeah, so the bugs, in the beginning it actually meant that some JSON schemas didn't work on Azure and they worked fine on OpenAI, and you get indeed an error that is not very descriptive. And actually the description that you get for the error is wrong. So you basically get a description for an error, you find a way to fix it, it asks you to add like a certain field to your JSON schema, you add it through many ways possible, you send your schema over and you still get the same error. So even the error looks descriptive and seems to tell you what's wrong, but it's actually not the error that's happening. So it helps with just starting with a simple pydantic base model and then just making it more complex over time. And usually you make like a small mistake somewhere or like some reasoning mistake in your JSON schema, and then you suddenly get an error. So build it gradually, make it bigger, and then you will see where the error occurs. But yeah, the error is not very descriptive and it gives you the wrong impression of what the error is. All right, I see that there is a question from the people at home. So question at home is, what would be a good trade-off in terms of number of iterations for looping between validation and prompting? Honestly, we validate every time we get an output, but we try to do most of the validation in code where possible. But because being a critic is so much easier than generating the output, you can actually use a cheap model as a critic. You can actually use a cheap model to validate the output. So what you can actually do is use, for example, GPT-4o to generate your output, and use 4o mini, which is really cheap in comparison and still very performant, to do the checking. To be honest, GPT-4o mini is price quality at this moment, in my experience, the most interesting model on the market. Like, it's very cheap, reasonably fast, and very performant. I hope that the Haiku 3.5 from Claude will catch up, but let's see. 4o mini is still cheaper and way more powerful than Claude 3 Haiku. So in that sense, I validate where it's important. I validate every time. All right. Are there more questions here in the room? Yes. Go ahead.
How do you ensure that you don't run into a timeout when asking the LLM and it's generating too long because you have an API?
Yeah. So question is, how do you not run into timeouts? Actually, I just make sure that my code can handle long wait times. So that's why I run it as a Docker container, in my case on Fargate, but you can run it wherever you want. And usually, it really depends on the number of outputs that you ask. So it's mostly dependent on that. So if you can get like a rough estimate on how long it will last, right? It's even if you're in the queue at OpenAI, the queue generally doesn't take huge amount of time. So you get a response in a reasonable amount of time. But yes, it can be long. So I just make sure that my code can handle the latency that is introduced by these models. Yeah, go ahead.
Response times of your API?
So around response times, so if you just use one field, it's like a few seconds. If you use 10 fields, it's 10 times, well, yeah, 10 times as long. So if we have calls with, I think up to 60 fields that we extract, and that can take 1 to 2 minutes. So, but it really depends on the number of fields in your JSON. So even if you put in a lot of data into the context window, the effect of that is actually pretty limited. The effect of the output size is the most determining factor on the response speed. So if you ask a lot of fields, it will be a lot slower. So if you really want something fast, try to reduce the number of fields in your JSON or your output format. All right. Any more questions? If not, thanks. And if something pops up, just come and talk to me. Don't forget to give us feedback on the talk in the app. And if you have more questions that weren't answered, ask me or come to the AMA session on tomorrow at 1:30, where we also have other experts that might answer your question. Thank you.